All right, we are Plastic Cracks Plus Plus, and my name is Andrew Rivera.
I'm Caleb Moore.
I'm Joshua Chastain.
And Nathan Lepker. So a quick little overview of the project. Our client is Dr. Warner, a construction management professor here at SIUE. Plastic Cracks was a senior project back in 2015. Dr. Warner was also the client for that one. Originally, she mostly just wanted us to fix the original plastic cracks. So a little background. So plastic cracks is a calculator that determines when it's best to pour concrete based on the current weather. We attempted to salvage the original project, but links to the weather service were broke. Discontinued libraries were in use. They were using PHP. So we just decided to remake the original plastic cracks so we could add our own flair and use a more modern framework. We'll go into more details about plastic cracks in the next slide. As the year progressed, we learned more about what Dr. Werner wanted this webpage for, so we decided to add a couple more calculators, including the bow calculator, TC Powers calculator, and the mixed design calculators. Again, we'll go into more details about these. So this webpage will mostly be used for students to use the calculators to learn, but also for any industry workers wanting to use the plastic cracks calculator. So next we'll have the plastic cracks calculator.
So the plastic cracks calculator is pretty much the same as the original project had it. It takes a couple of metrics from the weather service, such as air temperature, relative humidity, the surface temperature of the concrete being poured, and the wind speed to calculate the evaporation rate or the bleed rate of the moisture at the surface of the concrete. And then we take this value to help determine what the risk is of plastic shrinkage cracks occurring on the surface of the concrete, which can kind of damage the integrity of a new pour. We'll go into more details about how this was implemented whenever we do the product demonstration. Next, we'll have the boat calculation.
So the bow calculations is a set of equations to help determine the composition of a cement given a set of initial ingredients. So at the top right, we can see the actual bow equations that are in that blue page. And then directly below it, we have a example input. This is Portland cement. This is normal, regular old cement that's used practically everywhere. On the very right side, we can see the percentage of the ingredients used, where we have lime, silica, alumina. Directly below that, we have a breakdown of this type of cement with the different ingredients, the results. So there's also 4 different other types. So the normal Portland cement is type 1, which, as I said, is the standard cement that you see everywhere. But there is also 2 that are highly resistant to sulfates, which is used in, I believe it was dams and other structures that need high sulfate resistance. Type 3 has a high early strength for when you need a concrete that needs to set very quickly. And then type 4 has low heat while it dries, so that way it doesn't overheat. And then now we will have Nate explain the TC powers.
So the TC Powers calculator is named after a scientist. You can probably guess it, Mr. TC Powers. So he developed these equations in the 1950s. So he proposed a set of equations that could be applied to all Portland cements as one of the fundamental calculations in the cement world. All you need for these calculations is the water cement ratio and the degree of hydration. I'm not going to go into details about how all these outputs are calculated, but on the webpage, we're going to show the computations involved in calculating the outputs, like the volumes, evaporable water, porosity, gel space ratio. Then we're going to show a visual aid, like the one shown on the right of the slide. Next, we have mixed design.
So the mixed design calculator is fairly simple. The user will input the amount of ingredients they're using for their current design, and the output will generate certain characteristics and give the quality of the design that the user inputted, like feet, yards, pounds and other characteristics. So next we will do our product demonstration.
So the first calculator in our web application is our recreation of the original plastic cracks calculator. And this takes the zip code of the area that the concrete is going to be poured. So we'll just use Edwardsville, and the surface temperature of the concrete as after it's poured. I'll just do a sample of 62 degrees. And when you submit this, this gives you a bar graph for today and the upcoming week, which takes the forecast data and the weather metrics as discussed in the slideshow to calculate the evaporation rate. And based on this evaporation rate, you can see we have different colors for each of these bars. That kind of represents the risk of these plastic shrinkage cracks occurring. Obviously green, you'll have a much lower risk of them occurring. And as it gets closer to red or yellow to red, you have a higher chance of this occurring. So this just gives you a nice visual aid for when it'll be safe to pour concrete based off these weather temperatures. And we also gave the users the availability to download this chart as an image so that you can, maybe you need to pour concrete in multiple areas, so you could save the image and then you could come back and say you wanted to pour concrete in Godfrey and maybe it was a slightly different temperature, say just 60 degrees. You'll get your new chart. Looks like Godfrey will be pretty easy to pour this week. You can just download this image and just have a suite of your images so that you can maybe download these, print them off, and have them with you. Make it really easy to keep your calculations and know when it is good to pour. Next, we'll go over the Bogue calculator.
So as was said before, we have a set of equations that takes an input and gives an output for initial ingredients for the compounds that it creates. So for our example, we'll do 65, 20, 5, and 3, and 3. So now on the right hand side, we have two different little bar graphs. The left hand one is a visual breakdown of the values that we just input. And if we hover over it, we get a nice little tooltip that tells us how much each one is and what it is. And on the right side, we have the same thing with tooltips, but this shows the resultant compounds that are created out of these inputs. On the bottom left, we also have a easier to read, so that way you can see the numbers much more quickly and you don't have to hover over the bars multiple times in order to get all of them. So now if we say change these inputs slightly, so increase the lime by 1 and decrease the alumina by 1, and hit compare, the old bar for the results goes to the left, and now we have the results for the calculations we just did on the right side. So we can visually compare and contrast the two. So we can see that this one has 0 dicalcium silicate, as it doesn't have, and visually we can see that it has no orange bar. So now if we hit clear, this will take us back to the home page of Bogue. And now to demonstrate the buttons on the bottom right, these buttons represent the 5 different types of cement. So one was Portland cement, so if we click that, it gives us a preset calculations for the average inputs of that type. And now, after we have done a calculations, if we click, say, 4, it will compare whatever the old result was to a type 4. So the bar graph on the right is the resultants of a type 4 calculations. And that would be all for Bogue, and we will move on to TC Powers.
So for TC Powers, we have our input right there in the top left. So if we enter 50% and 75% and select compute, we get our outputs on the left side there. You can see our volumes, our gel porosity, evaporable water, all that fun stuff. And we have the visual aid on the right there with some more tooltips. So you can hover over, you can view all them. It'll show you the percents. So yeah, and then if you maybe you type in 43% and 100%, type compute again, everything it'll adjust and it'll just keep showing you what you want. So next we have mixed design.
The mixed design calculator is fairly easy to use. The user will just enter the information almost like filling out a form. And then as you can see from the output, the cubic feet's generated along with the SSD mix amount feet and also the SSD mix amount in pounds. And also, as you can see, you'll have the totals on the bottom as well. And so next we'll move on to our finalizations. And so to wrap up the semester, we still need to obtain some information from our client, Dr. Warner. And then we also need to serve plastic cracks through ITS. So, and then next we would need to do our final touches and make our website better for our visuals. And that is all.